Okay, so friends, we will try to see some more aspects of the receiving end circle diagram. So we had seen that the receiving end circle diagram. Let me draw it once more. So this phasor is equal to minus a upon b VR square. This phasor is, its magnitude is minus a upon b VR square. This angle is beta minus, and one more phasor is there, VS VR upon b at an angle beta minus delta. So let me draw that one more phasor. This is one more phasor. Draw a line. So this is the line. Now this phasor is having a magnitude VS VR upon B. So B is the magnitude of the B parameter, Vs is the magnitude of the sending end voltage, VR is the magnitude of receiving end voltage, and this angle is equal to beta minus delta, where beta is the angle of B, delta is the angle of delta with respect to VR. So if we consider this as a generator which is supplying supply voltage Vs at an angle delta through a transmission line to the receiving end, whose voltage is given by VR at an angle 0, and it is supplying the load of SR, which is equal to PR plus J times QR. And these are the A, B, C, D parameters of the line. Now once the line is there, its ABCD parameters are fixed. That means the magnitudes of ABCD as well as their angles. So magnitude of A and its angle alpha, magnitude of B and its angle beta, you cannot change once the line is ready. So we have got the summation of these two phasors, minus A upon B VR square, and this is another phasor Vs VR upon B. That summation is equal to the so again I should draw a line. Yeah. That is equal to the receiving end power SR. So this is equal to ER plus J times Q. So now if I fix VR and Vs in magnitude, is there any way I can change or I can serve a receiving end power which is different from PR plus CQ? Yes, I can change, because this phasor is going to be fixed, minus A upon B VR square, because we have fixed VR. A and B, they are the transmission line ABCD parameters, so they cannot be changed. This angle is beta minus alpha, so beta is also fixed, alpha is also fixed, being the parameter of the transmission line, so that cannot be changed. Here we are saying that we won't change Vs, we won't change VR. B is of course fixed, What can be changed? Delta can be changed. So if I change delta, then it is possible that it will, the magnitude of this phasor will remain same, only its angle will change. So let me draw another uh, with the help of compass. I will draw. Let me have this. Now I will be rotating it. So taking this as the center and this much as radius, because this radius is fixed, and what can change is beta minus delta. So how it will change? It will change according to the circle I draw here. Now of course P cannot go negative, so whatever is P, that can go only up to this point. Okay, so as I change the angle delta, now this is my new radius. Radius is same, in fact new angle. So I will draw another one from here to here, from here to here. So the magnitude is again VSVR upon V, but now delta has increased. So this is my new beta minus delta. So this is beta minus delta 1. And of course delta 1 is more than delta. So delta has increased. It has become delta 1, and therefore beta minus delta has decreased. So with this I am able to supply, at this point I was able to supply only this much of PR, and now I am able to supply much of PR. So let me indicate, this is my PR and this is my QR. So if I want to change or increase PR, I can do so. But have you observed one thing? As I because I'm not changing the locus, I'm not changing the magnitude of Vs, and VR being fixed. Okay, so it lies on this locus, and as it lies on this locus, along as it goes on increasing, VR goes on increasing. At this point, it becomes this. At this point, it becomes the maximum. So so this is my PRs. But have you noticed that as I switch from this phasor to this phasor to this phasor, now magnitude of this phasor is same, VSVR upon beta. Angle goes on changing, delta goes on increasing, or beta minus delta goes on decreasing. So what is happening to QR? QR was initially here. So let me see, draw with white line. So with the red one, this phasor, the QR was here. Now here QR has become negative from here to here. This much is, it has become negative from positive here to negative, and here QR has further increased. And now if you go beyond this, or if you increase delta beyond this, what happens? PR again reduces and QR goes on increasing. PR reduces and QR goes on increasing from here to here. So let me draw one more piece here. So now QR has become like this much. So from here to here is QR, and from here to here is.
So the maximum power that can be delivered is when beta minus delta is how much? Beta minus delta is 0. So maximum power is delivered
When B from 0 at this point, or B delta. So that is the maximum PR. So now I hope that you have understood why it is called as the circle diagram, because the locus of SR is on a circle which is having the center, this one, which is OC. So this is C, this is O. OC as the center, C as the center, and the radius as this much, CP. So I have this point as P. So this P will move along the circle, and that will dictate how much PR I can serve as a load. So if your load is more than this, then what will happen? It will not able to serve the load. It is not possible to serve the load if the load is more than PR max. Then what you have to do? Then suppose, let us say the load is something else, then more than PR max, then you increase the length of this VSVR upon V, so that load matches there. But along with that, you cannot independently control QR. So once you control PR, with that QR is automatically changing because it is on this loci, loci of the circle. So QR automatically changes. So it will deliver this much of PR, but then it will deliver this much of QR also. Here in this case, it will deliver this much PR max, but it will deliver this much of QR. So that has to be there. It cannot change. So we will see in the next lecture that you have to use some compensation devices if you want to serve PR which you desire, and the QR you have is something different than the QR given by this loci. Then that much difference between the existing and the given by this loci, that must be additionally employed at the receiving end. So we will see with the help of some more example the circle type. Okay.